Hello my geniuses, welcome to another biochemical lecture series. Today is your great science tutor Lorenzo, and today we'll be talking about ketolysis, which is the utilization of ketone bodies. In my last video we talked about ketogenesis, how ketone bodies are formed. All of them are under the umbrella of ketone metabolism. Aside from ketolysis, we'll also be adding ketosis too, because I promise you I'll be sharing it into another video. But if I leave ketosis on its own, it will be so short. So I'll be pairing ketosis with ketolysis now in the video. So my first video was on ketone bodies, which is ketone metabolism, the formation of ketone body, ketogenesis, while in this one I'll be talking about the ketolysis, which is the utilization of those ketone bodies that are formed, utilize it to make ATP, and also the symptoms or clinical correlation that comes when you have excess ketone bodies in the body. I'll be talking about them. So if you are new to my channel, make sure to subscribe and turn on your post notification button. Always stay here, don't leave. Just stay to the end, because I'll be giving you useful tips that you'll be needing for your exams. Don't miss out, because it's very important you follow me to the end, because this is a broad view of biochemistry where you learn about the metabolism of the body, and I'm giving you with connection easy ways that you can use in making your what diagnosis. It's not only about the exams, it's about making diagnosis and informed choice when you're about to choose answers for your exams. Now let us jump right into the video. Now if we are to start, what is ketolysis? So ketolysis is a metabolic process which involves or includes the utilization of ketone bodies homeostatically. Always use the one homeostatically, because in homeostatically, when the body sees that the ketone body is too much, it has to utilize the ketone body for something good. Because when you accumulate excess ketone body, it could be harmful to the body. So it's a metabolic pathway which involves the utilization of ketone bodies hemolytically to produce acetyl-CoA. So acetyl-CoA enters into a TCA cycle to form ATP. So when we utilize ketone bodies to form acetyl-CoA, which acetyl-CoA enters into a cycle to form ATP, we call it ketolysis. So ketolysis, lysis, breakdown of ketone bodies. So we utilize it to make ATP. So where does it occur? It occurs in the extrahepatic tissue. Unlike ketogenesis occurs in the liver and in the kidneys, but this one occurs in extrahepatic tissues that are not the liver. So because this tissue utilize energy, so they convert ketone bodies into energy so that they can utilize them. So ketogenesis squarely occurs in the liver, while extrahepatic tissue uses these ketone bodies to form ATP. But lastly, remember in the last part I did in ketogenesis is reduction to beta hydroxybutyrate. So when I reduce acetoacetate to beta hydroxybutyrate, it could pass through circulation to other tissues, because if you leave it as acetoacetate, it cannot pass through to other tissues like the brain. So the brain cannot utilize the ketone body if it is an acetoacetate. So you have to reduce it to beta hydroxybutyrate so that it can go to the brain, it can go to the lungs, it can go to the heart, it can go to even the testes and other areas that have barriers there. So it can go to them and supply them. But if you leave it as acetoacetate, it will not work, because it's acidic and it cannot pass through the barriers of some circulations. You get it now? So now I told you that it occurs in extrahepatic tissue. What is the stimulating factor? The same thing: fasting, starvation, strenuous exercise. The same thing with ketogenesis, because this is just a hemostatic pathway where we break down the ketone bodies and utilize them for ATP. So fasting, starvation, strenuous exercise. So when you fast and when you are starving, or when you are undergoing strenuous exercise, your body is releasing glucagon. The glucagon is used to form glucose, so that your glucose can be used for ATP. So that's what your glucagon is doing. So also cortisol is released during stress. So when cortisol is released, what happens is released alongside with catecholamines. So if they ask you what is the stimulating factor of ketone body metabolism, they have the same thing. You have fasting, starvation, strenuous exercise, presence of glucagon, and the release of cortisol. So but states like first state inhibit ketone body metabolism. So when you eat, your body eliminates ketone body cannot be formed. Ketone body is only formed when there is excessive beta oxidation. So When there's no excessive beta oxidation, there's no ketone bodies. So when you are eating, instead, you don't form ketone bodies, you don't form beta oxidation, you store those food as fat and what glucose, so you don't just use them up. So during first stage, ketone body metabolism is inhibited, ketogenesis and ketolysis. So when I talk about ketone body metabolism, I'm talking about the formation of ketone bodies and its utilization. So they are inhibited. So when you eat, also insulin is stimulated. So when insulin is secreted, what happens? It will also inhibit ketone body metabolism. Also tyrosine. So tyrosine is also increase the basic metabolic rate. So at high amount of tyrosine, what happens? Ketolysis will be inhibited alongside ketogenesis. So these are the stimulating and inhibiting factor. So if we are to move into the biochemical pathway, so what will be the first step? Remember what happens. We did something. We have already reduced acetoacetate to beta hydroxybutyrate in our last video by oxidizing NAD plus, by oxidizing NADH to NAD plus. That's what I did in my last video. By beta hydroxybutyrate dehydrogenase. That is what I use to reduce acetoacetate to beta hydroxybutyrate. So the information of beta hydroxybutyrate in my last video, I'll be able to pass through the blood freely and enter some places that has barrier, like the blood-brain barrier, blood-testis barrier, in the lungs, anywhere that have barrier, because those barrier, in presence of acetoacetate, I can't enter there. So when I reduce to beta hydroxybutyrate, which is the reduced form of acetoacetate, I can easily pass through all these barriers. So now I'm in beta hydroxybutyrate. And I pass through different barriers and I share to different tissues. Then what will I do next? I will not be oxidized now. You get it now? So the last pathway for beta oxidation. So the last pathway for ketogenesis, what happens is reduction of acetoacetate to beta hydroxybutyrate. So now the continuation of that is, now I already have my beta hydroxybutyrate. So now I already have it. I will reoxidize acetoacetate back. You get it now? I will reoxidize acetoacetate back, because before I reduce it. So now I've passed already to the barriers already. Now I'm already in the tissue, so I have to go back by oxidizing beta hydroxybutyrate to acetoacetate. So now I've oxidized beta hydroxybutyrate to acetoacetate. What will I do? I'll be reducing NAD plus to NADH. So remember, when you have NADH, what happens? You can use it to get 3 ATP in the electron transport chain. So this has shown me that these steps are important for ATP formation. And what enzyme? Beta hydroxybutyrate dehydrogenase. Beta hydroxybutyrate dehydrogenase. Remember, it's still a dehydrogenase reaction, but in the first reaction there was a reduction. I get him now. And here there's oxidation. So now that I've utilized my beta hydroxybutyrate, I've then reoxidized it back to acetoacetate while reducing NAD plus to NADH by the enzyme beta hydroxybutyrate. The next thing I'll do now is to condense acetoacetate with succinyl-CoA. So if I condense acetoacetate with succinyl-CoA, what will I get? I'll get Acetoacetyl-CoA and succinate. Acetoacetyl-CoA and succinate. Remember that now I have acetoacetate. I'm going back to where I started from. I was coming from condensation of acetyl-CoA, which is 2 molar acetyl-CoA, to give us Acetoacetyl-CoA. Then I'll condense another one again. I get HMG-CoA. Then I now use a lyase enzyme by cleaving HMG-CoA to get acetoacetate and acetyl-CoA. Remember how I started in ketogenesis. So I'm going back now. So I have acetoacetate now. So what will I do? Now, if I condense acetoacetate with succinyl-CoA, I'll get Acetoacetyl-CoA, and my succinyl-CoA will become succinate. Are you getting now? Always remember. So condensation reaction involves that here I'll condense acetoacetate with succinyl-CoA to get Acetoacetyl-CoA and succinate. The succinyl-CoA will be oxidized to succinate. Then I'll also convert acetoacetate to Acetoacetyl-CoA by the enzyme thiophorase. Again, there will be oxidation of succinyl-CoA to succinate, which is a normal substrate of TCA cycle, and also there will also be conversion of acetoacetate to Acetoacetyl-CoA by the enzyme thiophorase. So succinate now can continue the TCA cycle to form ATP for ourselves. So the first one here, I got NADH, which can enter into the electron transport chain to form ATP. So now when I utilize succinate-CoA, I got succinate, which can also enter into the TCA cycle to get energy for me. Now I have Acetoacetyl-CoA, so what will I do? I'll cleave my Acetoacetyl-CoA with what? Thiolase. Remember the enzyme thiolase. So if I cleave my Acetoacetyl-CoA with thiolase, what will I get? I'll get 2 moles of acetyl-CoA. So Acetoacetyl-CoA with thiolase now get 2 moles of what? Acetyl-CoA. And that 2 moles of acetyl-CoA now enter into the TCA cycle. The job is to make what? ATP. That is how I've utilized it. For the first one, what do? I oxidized by converting what? Beta-hydroxybutyrate to what? Acetoacetate. Are you getting now? Either by reducing NAD plus to what? NADH. After I oxidize, I condense it with succinate-CoA. So when I condense it with succinate-CoA, I get succinate, which enters into TCA cycle, and I get Acetoacetyl-CoA by the enzyme thiophorase. Don't forget, it's here. Just write it down and listen and recite. Now I've gotten Acetoacetyl-CoA. I use my thiolase to cleave. So when I cleave what? Acetoacetyl-CoA, I'll get 2 moles of acetyl-CoA, which enters into the TCA cycle to form what? ATP. Hope you understand that. So one thing to take away here is that ketolysis occurs in the extrahepatic tissue, while ketogenesis occurs in the liver. Also, acetoacetate is untimely converted to 2 moles of what? Acetyl-CoA, because it has to convert to Acetoacetyl-CoA with succinate-CoA, and then later forms what? 2 moles of what? Acetyl-CoA. And also acetyl-CoA enter into the TCA cycle to generate what? ATP, which we have talked about. So now we have done ketogenesis, we have done ketolysis. So lastly, what we'll be doing is what? Ketosis. So I hope it all made sense to you and you have understood everything I've talked about in utilization of ketone bodies, which is ketolysis. So we'll be moving over to what? Ketosis, which is the last one. So I'm supposed to add it here in this video, but I want to separate it now so that it will be easier. I don't want to jam pack everything, so that you get the idea for each video. So ketosis occurs when there's excess amount of what? Ketogenesis. So when there's excess amount of ketogenesis and the ketolysis do not occur homeostatically, what happens? It will form what? Ketosis. So in my next video, I want you to go to the next video now, because I told you that we have done ketogenesis, now we have done ketolysis, we are moving over to what? Ketosis. Are you getting now? So like I said, it's not 3 video. Watch it step by step. It's quite easy. You get it now? I made it short so that you have to what? Understand. You get it now? So if also you need the PDF, you just have to send me a message or drop a comment on the comment section that you need the PDF, then it will be sent to you. Are you getting now? So I'll be seeing my next video. Bye bye.